Welcome to STEMsphere, a world of discovery. Hello everyone! In this video, we will discuss an incredibly important topic in general mathematics, the one-to-one function. I know this might be difficult and a bit intimidating, but I will do my best to discuss, so we're going to have some fun and knowledge with it. Okay, now let's start. First, we need to determine this whether the function is one-to-one. So now, I will give you some problem, then let's determine if it is one-to-one or not. Okay, number 1. The relation pairing an SSS member to his or her SSS number. Well, the answer is one-to-one function. Well, the function is pairing an SSS member to their SSS number is likely one-to-one, assuming each member has a unique SSS number. And one-to-one means each input, which is the member, corresponds to a unique output, which is the SSS number, and vice versa. So the answer is one-to-one function. Okay, number 2. The relation pairing a real number to its square. Well, the answer is it is a function but not one-to-one. Well, because different real numbers can have the same square. For example, both positive 2 and negative 2 is square to 4. Like example, the real number is 4 and the square is negative 2 and positive 2. It can be equal to 4 even it is positive or negative squared. So the answer is not one-to-one. But remember, it is a function but not one-to-one. Okay, number 3. The relation pairing an airport to its airport code. Well, the answer is one-to-one function. We know assuming each airport has a unique code, one-to-one is achieved when each input, which is the airport, is associated with a distinct output, which is the airport code. So the answer is one-to-one function. Alright, now let's go to the definition of one-to-one function. Well, the function is said to be one-to-one if whenever x sub 1 is not equal to x sub 2. For any x sub 1 and x sub 2 in the domain of f, then fx sub 1 is not equal to fx sub 2. Equivalently, f is one-to-one if fx sub 1 equals to fx sub 2, then x sub 1 is equals to x sub 2. That is the same, y value is never paired with two different x values. Well, in simpler terms, if the function of two distinct inputs is not equal, then the inputs must also be different. This ensures that each unique input corresponds to a unique output, preventing two different inputs from producing the same output. Okay, for example, determine whether a function is one-to-one. For the following function, the domain represents the first grade in the first semester of 5 females, and the range represents their second grade of the first semester. Based on the picture below, the first semester and the second semester grade, the 94 grade is connected to the 98 grade. Then the 93 grade is connected also to the 98 grade. The 91 grade is connected to the 97 grade. The 90 grade is connected to the 95 grade. And last is 92 grade is connected to the 96 grade. The answer is not one-to-one function because two different first grade, which is the 94 and 93, both connects to the same second grade, which is the 98. This violates the conditions for a one-to-one function, as different inputs are producing the same output. Therefore, the function is not one-to-one. Okay, another example. Let's determine it whether a function is one-to-one. As you can see, it is a one-to-one function because there are no two distinct inputs that corresponds to the same output. Okay, the number 2. Well, it is a function but not one-to-one because there are two distinct inputs that corresponds to the same output. Example, the domain -2 and -4 has the same output to the positive 1. Alright, let's talk about horizontal line test. A function is 1-to-1 if each horizontal line test does not intersect the graph at more than one point. And the vertical and horizontal line test, all functions satisfy the vertical line test, while all 1-to-1 functions satisfy both the vertical and horizontal line test. Now, let's go to the example. Tell whether the following graphs are not 1-to-1 or 1-to-1 function. The first picture, which is the zigzag, it is not 1-to-1. Because if we use vertical line test, it's passed the test, while the horizontal line test, it didn't pass the test because the line intersects 2 points. Well, same with the second picture, which is the curved one. It is also not a 1-to-1 function. And the third picture, it is 1-to-1 because it is past the vertical and horizontal line test. Alright, let's go to the inverse of 1-to-1 function. Consider the table of values for a certain relation below. The question is, does the table represent a function? Is it 1-to-1 or not? Well, the answer is, it is a function and also it is a 1-to-1 because it has a unique range and domain, which is the x and y values. Now, let us invert the values for x and y. The question is, do this table still represent a function? Well, the answer is, it shows that the table does not represent a function because there are some y values that are with more than one x values. The previous scenario shows that when we invert function, if the x and y values of a 1-to-1 function are interchanged, the result is a function. But if the x and y values of a function that is not 1-to-1 are inverted, well, the result is no longer a function. Well, the definition is, let f is a to b be a 1-to-1 function, then the inverse of f, denoted by f to the power of -1, is a function with domain b and range a. Take note, a function has an inverse function if and only if it is a 1-to-1. Well, that's all. Thank you for watching. I hope you've learned something new and interesting about this topic. If you have any question, feel free to ask below comment section. I hope you found this lesson helpful. See you next time.